Today on the big island of Hawaii, everyone is watching Mauna Loa, the behemoth mammoth volcano that makes up a huge chunk of the island itself. This is one of the largest geological bodies on the planet Earth. Largest volcano for sure, 31,000 feet from tip to the base of the volcano. It's an incredibly large object, sitting over top one of the most active hotspots on Earth, the Hawaii hotspot. So we have a magma chamber we know is starting to fill up and maneuver again after many years of lying relatively dormant. Back in 1950, this area had a fairly large eruption, and again in 1984, but it's been relatively quiet this past century. Maybe not for so long, because we had a 4.2 magnitude earthquake along the eastern flank of Mauna Loa, which has been over the past few years steadily increasing in its microquake activity and also in the slight deformation or tilting of the land above the magma chamber as it fills. Lava flows are hot and runny and basaltic. They can run for miles and miles away from Mauna Loa. And so any of the major cities or tourist centers around the Big Island need pay attention, because in a matter of days, weeks, even months, these lava flows could reach the cities and be a hazard for the people that live there. So everyone is watching the volcano, keeping their evacuation plans in mind, just in case one day soon Mauna Loa comes to life again. Just when you thought you knew your planet. This week, an Australian science team published in the Journal of Geophysical Research new information that could suggest that there's an additional fifth layer to the Earth. And we all grow up learning that there are some basic layers to the Earth, all based on sound geophysical concepts. The crust, the outermost layer, the mantle, the thick inner layer, and then our core, dividing into a liquid outer core and a solid iron and nickel inner core. Now, by analyzing geophysical data, researchers now believe there could be a potential fifth layer, a part of the inner core in which the iron structures change, slightly affecting the geophysical passage of waves through the Earth's core. We can't see the Earth's core or its interior, but we use the passage of certain types of geophysical seismic waves through the Earth to interpret what those layers are made up of. We know that shear waves, for example, won't pass through fluid. So we know the outer core is made up of a liquid because we don't see shear waves pass through it. Those compressional waves, though, do. They pass all the way through, and there's a very slight shift in the data that certain algorithms and computer programs have been able to suggest that perhaps there is a boundary left over from an early set of cooling events when the world first started to form that can be seen in the data, suggesting that yes, there could be an inner core, as though the core wasn't confusing enough with two layers. Not only are we adding layers to the Earth, but we're changing the time scale too this month. The International Union of Geologic Scientists ratified a change to the Middle Pleistocene period, 770,000 years ago to about 126,000 years ago. This new period in the Middle Pleistocene is called the Chibanian, and it relates to rocks that show us the reversal in the geomagnetic field of the Earth about 770,000 years ago. The rocks outside of Ichiban City in the province of Chiba show a beautiful outcrop in which we can see, through marine silts, volcanic ashes, and other sedimentary rocks, the transition as the Earth's magnetic field rotated from current-day South Pole to North Pole. We don't fully understand all of the impacts that occurred and were felt by ancient people or animals or plants during this transition, but we think that it occurred over a quite long period, about 22,000 years. Currently, our Earth's geomagnetic pole, positioned in the North Pole, is starting to wander more and more. And many scientists speculate that soon our North Pole may want to swap back down to the South Pole, giving us another geomagnetic reversal.